So, welcome everybody to Token System webinar series. We are very happy to have so many of you joining us today for the fourth and the last session about legal engineering. My name is Stefania and I'm BerChain Association Manager. BerChain is a non-profit member-led association based in Berlin, promoting and connecting the local Berlin blockchain ecosystem. Today's event, Token Systems, is a series of weekly webinars running through this April to explore in-depth token-based systems in different tracks. This webinar episode will uncover what is legal engineering and aspects about on-chain disputes. This session will be recorded and is also streaming on YouTube. We will have a live Q&A session at 5:50. So to ask questions, please use the Q&A function in the bottom of the screen. This will allow your question to be seen by the panelists and be answered towards the end of the session. In addition to the previous sessions, this time, we kindly ask you 1 minute of your time for an anonymous poll about the audience background that we will be sharing during the first minute of Clement's presentation. So each of you who are attending is invited to contribute to this quick poll. This will help the speakers to adjust the terminology adopted for this webinar according to the audience background. Thank you. It's my pleasure now to introduce the speakers today. Clement Lesaege, CTO at Kleros, presenting on-chain disputes on the Kleros platform. Hi, Clement. Thank you for being here.
Hi, Stefania. Thanks for hosting us.
And Esener, compliance manager at Bitbala, presenting legal engineering. So, hi, Esen. Thank you for being here.
Thank you for having me.
I'll hand the word then to Clement, who is the first presenting.
So let's start with Kleros, with on-chain dispute on Kleros. So when you are using smart contract, you can have two main kinds of smart contract. You will have contracts that we will call like complete contracts, where there is no need of human intervention. So for example, if you want to exchange a crypto asset against another crypto asset, everything can happen on chain. It's completely objective, and you can write some code and write some rules, which will say, okay, if someone put this crypto asset, someone put this other crypto asset, you swap those assets, you swap the control of those assets. So it's what most of the contracts are used for, but it's quite limiting because you cannot interact with what is off-chain, and you cannot incorporate subjectivity. Now you have another field, which will be incomplete contract, where you agree that the contract on-chain will be incomplete because it will refer to some elements off-chain or some elements of subjectivity. So for example, if you want to buy some good online, you don't just interact with what is happening in this chain. You will also have an interaction with someone shipping a good for you. But the chain itself cannot know if you got this good or not. Another example would be some content moderation. You make a decentralized platform, like think something like a Facebook or a Twitter, but decentralized. How do you moderate content? The chain itself cannot know if a content is hate speech or not. So for that, you will also need some human intervention. And that's where you have incomplete contracts that Kleros can be useful. Sorry, I got the poll. Okay. So let's give an example. where here you have Alice in France and Bob in Argentina, and Alice wants to pay Bob to make a website for her. So they will agree on some specifications, but then when the website is done by Bob, Alice will say, no, like, it's not what I asked. And Bob say, no, like, I did my job and now you have an issue. Where if Alice already sent the money to Bob, then Bob has the money. If Alice didn't pay yet, well, Bob has no way to get his money back. So you have a problem, you have this dispute because here this contract is incomplete. The chain cannot know if the website is done correctly or not. So that will be the first simple example of the use of Kleros, which is using escrows. So here you will have Alice, which will deposit some ETH for some crypto assets into the smart contract. And if everything goes correctly, once the job is done, Alice will call the contract, and this contract will send the crypto assets to Bob. But now, if you have a dispute, you will have a call to Kleros. You will get jurors, which will look at what Alice has to say, what Bob has to say, and they will determine whether or not Bob complied with the specification, and so whether or not Alice should be reimbursed or Bob should be paid. So here, the juror will say, okay, Alice is right in this dispute, and she should get her money back because the website does not comply to what was asked. So automatically, once the ruling is given, the contract will send the crypto asset back to Alice. Now we have the question of how are jurors selected, and why would they actually do their work? Why would they actually look at cases, and why would they actually vote correctly, vote for the honest party? So Kleros, it's a random drawing system. Oh, I just got the result of the poll. So mainly business and legal and engineering. So pretty much even. Okay, let's go back to the presentation. Thank you for completing the poll. So it's a random, it's a system with a random drawing. So one token is one chance of being drawn. Some people may feel that weird, like why not one person, one chance of being drawn? The main issue is the civil attack. If you allow one person to be drawn, one person having one chance to be drawn, someone can just make tons of fake accounts to get a lot of chance to be drawn. So here we draw through PNK, we draw through three PNKs, and people owning those tokens are jurors in the case. Now they vote, they decide, most of them vote for Alice, but one voted for Bob. Now we have the other problematic, which is how do you incentivize jurors to vote honestly and do their work, not just vote randomly or accept bribes. So all of that, the idea is that if you vote coherently with other jurors, you will be rewarded. If you don't vote coherently with other jurors, you will be slightly penalized. So it's over time. Even if you are honest, sometimes you will vote incoherently compared to other jurors. But overall, if you are honest, you will most of the time be coherent. While if you are voting randomly, you will most of the time be incoherent with the other jurors. So here, you will have some arbitration fees, which was paid by Bob. Alice will also have deposited some arbitration fees, but in this case, because she won, she will get them reimbursed. So Bob, arbitration fee will be used to pay the jurors, which voted for Alice. And you also have some token redistribution, where here you have Ignacy, who did not vote for Alice, who will lose a bit of tokens to the other jurors who voted for Alice. So this idea is the shelling coin mechanism. So let's ask everyone which square you will pick if your goal is to pick the same square as the majority. So I will look in the chat. Oh, actually, I don't see the chat here. Maybe it's oh, I can see the chat now. So which one? So we have one A6, D4, the red A6, A6. Okay, so we can see that most of the participants are selecting the red square, which is A6. And all of the square, all of them could be a focal point. Like if everyone were to choose C3, yeah, that's fine. Everyone would be right and everyone will win. But here you have something which stands out from the other squares, and it's the red one, which is in A6. In the case of Kleros, the decision which would stand out is the honest decision. So that's where the juror will tend to congregate and vote for this honest decision. And that's why if you are voting coherently with the other juror, you are more likely to have voted for the honest decision. So the global idea is that on average, users which are giving value to the system will win some money, while people who are trying to game the system, for example, by voting randomly, will lose some money on average. So here you can see the idea behind drawing by tokens. And in particular, if you have someone making fake accounts, like the last one, because he doesn't have any token, it doesn't give him any extra chance of being drawn. But obviously the downside is that some people which are a lot of token get more chance of being drawn, and it's not just a one person, one vote, it's a staking system. So it's a one token, one chance of being drawn. Now we can ask another question, which is, how could this system be scalable? Because if we ask everyone to vote on every dispute, well, either the jurors, they're gonna be paid at a decent rate. So in this case, dispute will be extremely expensive. Or if the arbitration fees are low, well, they are not gonna be paid much and they are not gonna be incentivized much. So we have this random drawing system, but then if you only draw a few jurors, it may be easy to bribe them. So here, let's say you have two of the jurors which are malicious or just voting randomly and have voted for Bob, while the correct result is Alice. What we have is we have an appeal system. So you can double the amount of juror if you make an appeal, and the more appeal you make, the more juror you will get. So you can actually get a quite decent amount of jurors. And if you get a lot of jurors, ultimately, if you still have the juror voting incoherently, it will basically mean that the majority of the token belong to people who will vote incoherently. So ultimately, you end up into a problem, which would be the 51% attack, when you need to get the majority of the tokens to attack the system. And you don't just need to bribe a few jurors in the first round. And because people know that you can have appeals, most of the time, jurors, even in the first round, they will behave correctly and they will not take bribes and they will vote coherently. Obviously, when you make some appeal, it's taking some time, but we ask people to put some deposits, and the deposits are reimbursed to the winning parties. So you can effectively delay a ruling, but the more you delay the ruling, the more it will cost you, and the more juror will be paid. Now we can ask something which is always important to ask when you are looking at a token system, which is, why do you need a token? Like, why not just use ETH, for example, because Kleros is built on Ethereum, so all the users already have ETH. So let's look what would happen if we were to use ETH compared to PNK. The first reason is about the attack budget. So how much capital do you need to make this attack? And if you want to buy 15% of the ETH used on Kleros, taking Kleros, it will cost you approximately 15% of the ETH taking Kleros. Because sure, you're going to buy ETH, you're going to increase the price a bit, but most of the value of ETH is not linked to Kleros, so the price will remain almost stable. Now, if you want to do that with PNK, which is specific to Kleros, you will increase the price by a lot. And you'll probably not even find 15% of the PNK, which will be on sale in exchanges. So it makes the cost of the budget of the attack way higher by using a specific token. Second, what happens if you succeed in the attack? So if we are to use ETH, well, okay, you got control of the court, and now you control the court and nothing bad really happened to you. Now, if you have a specific token and you get 15% of this token and you make malicious decisions, people are going to stop using Kleros, or at least are going to stop using this version of Kleros. So the token will be worthless, because why will the token have any value? Because it gives you some chance of being drawn as a juror, which will give you arbitration fees. But now, if people don't trust Kleros anymore, they will not select Kleros for their dispute, they will not pay arbitration fees, so there will not be any reason to hold PNK. So in this case, you will destroy the value of a token and this token is the token that you mainly control. So you will impact your capital. So that will make this attack having a really high cost. And finally, about recovering from attacks, if you were to use ETH and you get 51% of the ETH, well, you cannot really do anything. You could say, okay, I'm going to make a new Kleros, but then the attacker can just move its ETH from the old Kleros into the new one. So you did not really solve anything. Now, with a staking system with a specific token, if some attacker were to be able to get 15% of them and make malicious decision, you could make a copy of Kleros, copy everything except the token balance of the attacker. So basically, you make a Kleros clone, but without the attacker tokens. And in this case, like the attacker will lose his token into like the valuable Kleros, which would be the fork, because it would be the honest one. Fortunately, all of the situation, they should never arise, because the simple fact that they could arise will mean that it's not interesting for an attacker to try those attacks. So we can explore how Kleros work at a high level. Now we can also look at like how would people use Kleros, how people are using Kleros. So Kleros, it's not a standalone application, it's really a dispute resolution brick. So you plug Kleros into some other systems, generally some other decentralized application. We sometimes saw people using Kleros in like non-blockchain context, but that's mainly to get some insight at what the population will think. But where it's really interesting is when you plug it with other decentralized application, and where Kleros decisions are automatically enforced by those applications. So we have these three main use cases. We have what we will call TCR, which would be token created registries, where you want to create some information. So that was the example of the social network. Currently, we don't have any social network with Kleros, but we have Curate, which is an application to make lists of any object. And we have also a curated list of token, like token in Ethereum, or NFTs or ERC20 tokens, and you want to verify that the tokens are correct because you want to prevent people from making fake token and trying to sell them. So you have this content curation. We have an escrow where you can set up transaction, as in the first example with Alice and Bob, where you can basically make a conditional payment on any condition. So that could be some work being done, some product to be delivered, some token on the chain to be delivered. You can write any contract that you wish. And we have this Oracle use cases where you have application which will refer to some question which are not related to the chain, like some question about the general state of the world. For example, who won the US election? When was the last earthquake in San Francisco? Any kind of question which cannot be known by the chain itself. And you can see here how the current Kleros ecosystem looks like. And if you look at this picture, what is really interesting that you see this modularity, where you have people making some application which are doing one really specific things. For example, we have reality.eth, which is an Oracle. And on this, you will have a reality card, which is a prediction market, same as Omen. You will have SafeSnap, which will be an application to verify that the decisions which are made in DAO are properly executed. You will have Proof of Humanity, which is a registry of humans. on which you can get some tokens which are distributed equally to every human. So you can see the idea. Kleros, it's not a company. It's really a protocol which can be used as a brick when you are making an application, and you can like stack those bricks and stack bricks outside of those bricks to create dApp ecosystems. We can now look at a few applications which are currently running. So this is the Escrow, as we saw with the Alice and Bob case, where you can create any contract. You can specify the condition that the recipient will be paid. And if like the recipient doesn't fulfill those conditions, you can say that it did not comply with the agreement, and you can create a Kleros dispute. The token registry that I spoke before, where you want to create some token to make sure that they are real token and they do not bring fake information, because otherwise you could have people in trading platform making a fake PNK, for example, and trying to sell it. That already happened. So we can look at the workflow of a curation case with token curation. So here, Alice wants to add PNK to a list. So she will put a deposit. Bob is watching the list, and because PNK information are correct, it doesn't do anything. So the token is accepted, and Alice will get her deposit back. But now, if she tries to put a token which is fake or doesn't follow the list requirements, Bob can see that this token is not a token which will belong to this list, put a deposit, and that's going to create, as we've seen before, a Kleros dispute. And since the juror vote to reject the token, Alice will lose her deposit and it will go to Bob. So that's incentive to protect the registry. You can see an example of the BerChain, not BerChain, BerChain case, where you had this registry to curate some token to be put on an exchange. And you had the pretend CTO of this project, which pretended to work at Oxford Blockchain Research Laboratory. And someone looking at that, like, I don't think this exists. And he called, he sent an email to Oxford, which I know, like, I don't know any Scott Bingley, and we don't have any laboratory called this way. And so that was an example of how they were rejected and they lost their deposit, and they managed to protect the list, to create a list of tokens with some specific qualities. We have a real issue that we spoke before, which is particularly useful because it's used by Crypto Unlocked and Omen. So in Crypto Unlock, it's for some crowdfunding campaign, but the people making the campaign are only paid once they made what they say that they will make. So for example, if they make a game, people can put the money, so they know that if they make this game, they will get the money, but they will only get the money once the game is released. And if you have a dispute on whether this game was released or not, that can go through this oracle, and ultimately that can go to Kleros if people do not agree on whether the condition of the crowdfunding were met or not. And you have Omen, which is a prediction market, where you can take tokenized position on any event. And in particular, what made a bit of noise recently was the US presidential election, where you had people taking a side on like getting some basically betting on Trump, betting on Biden, and we had a pretty large dispute because you had some people which would were arguing that Trump did not lose, or at least did not lose yet, because they were contesting the result of the election, and so you got this dispute on Kleros. Well, jurors voted like maybe 95%. They voted that actually Biden won the election, and this means that people who had bets on the Trump side will have lost their bet, and people on this bet on the Biden side will have get rewarded by the Omen system. Recently, we also had proof of humanity, where if you remember, I spoke a bit before about fake accounts. It's an application which is there to fight against this fake account by allowing people to register, but register only one time. So here it's also a curated list, and here we are basically creating ourselves, like creating humans. So if people try to register multiple times on this list, they will get challenged and removed from the list. And in particular, it's really useful because you can use it to distribute a UBI, like a token that you distribute equally to everyone, 1 token per hour to everyone who is registered. And you will also quite soon see that on Gitcoin, where it's used to prevent a fake account in a quadratic funding. So to conclude a bit, so Kleros, it has been now like a quite tested system. We got more than $4 million, which went through contracts secured by Kleros. Obviously, that doesn't mean that it's $4 million worth in dispute. Like most of the time, the simple fact that you could make a dispute means that you will behave honestly in the first place. We got over 380 jurors which ruled cases. There are more jurors, but some have never been drawn. And we solved 641 cases. So I will thank you everyone for listening to this presentation, and you can add your question for the Q&A, which will happen after Esen presentation.
Thank you so much, Clement, for this interesting presentation, also for the BerChain use case. We already have a few questions for you. We are going to go back to that at the end of the session. So I lend the word now to Esen. Are you with us, Esen?
Yes, I am. I'm going to share the screen now.
Thank you.
And hopefully it's on, right?
Yes.
All right. So thank you everyone for coming here and being with us today. I'm Esen and I'm so excited to be here to share my thoughts about legal engineering in token systems. And before I jump into the topic, I want to give a little bit information about myself. I'm currently working as legal manager at BitWalla. And of course, before my working life, I studied law. And during my master's studies in IT law, I became the victim of my curiosity, basically. Because back then I heard the words like Bitcoin, blockchain, and smart contracts. And I found it really interesting and I started to read about it. And then I basically found myself into the rabbit hole of this blockchain. And today I'm going to be talking about legal engineering and how I see it and about my predictions and based on my observations. So some of the things might sound a bit fictitious for you or maybe not. So you're going to decide it by yourself at the end of this presentation. And speaking of BitWalla, I also want to introduce it to you. And at BitWalla, we're offering you a bank account, a Euro bank account, connected with a Bitcoin and Ethereum wallet. And you can make your trades directly from your bank account without going to an exchange to buy and sell your cryptos. And we are also offering a Bitcoin interest account in collaboration with Celsius Network, so you can lend your Bitcoin and earn interests. And quite recently, we started to offer custodial wallets for Bitcoin and Ethereum. So if you are interested in our product, I'm sharing you my link, my personal link on the right side as a QR code. If you sign up with this code, you're going, and if you make your first trade, then you're going to get 50 euros bonus. But also a disclaimer, we're currently accepting the customers who are residing in the EEA region, so European Economic Area. So I'm just keeping the slide 1 or 2 seconds more for those who are interested. Now let's start with the topic. So I want to start with the 3 stages of internet to have an introduction to legal engineering, because I want to show you like where we come from and where we're heading to. So this classification of the internet is from Ethereum, and I find it very interesting. So when internet was first there, like when it just first occurred, it was the use case of internet was only to exchange information between scientists and academicians, and there was no commercial use. So the protocols like HTTP or FTP were created just to support this information exchange. Then slowly we started to have more services on the internet. We started to buy products, sign up for services, and commercial use began. And of course, online payments possibility also started. So this is why we needed more secure protocols like HTTPS or SSL just to support this online payment mechanism as well. And also in this phase, we started to make our agreements on the internet. So you may have seen thousands of terms and conditions already, or license agreements when you want to buy a piece of software. And the predictions are that we are currently moving towards the Internet of Agreements due to blockchains, artificial intelligence, and automated logistics. So basically, because of the technologies that the Industry 4.0 are offering us. And what's particular about this phase is that now we have a chance to program the agreements, actually. You might have seen this news from Decrypt on the 12th of April, but currently a house in Kranzberg in Germany is being auctioned as an NFT on OpenSea, which is an NFT marketplace. And the seller of the house is basically selling the house on this marketplace. But currently, the buyer of NFT, of course, will not get the ownership of the house on chain. So the buyer would get the contact details of the seller to actually make the transaction in real life. So this is why it's not the maybe most sophisticated case of NFTs right now, but I believe that it's a great indication that what we are heading to. So speaking of agreements and its programmability, I think we are in a good place to start to talk about legal engineering. The crypto economic system flowers that you see on the slide has been introduced by Clement Lesaege and Michael Zagam. Also, you might, if you joined in the earliest sessions of this event series, you may already be familiar with this flower. But crypto economic systems actually are quite interdisciplinary systems and which requires know-how from multiple disciplines, including engineering, finance, game theory, political science, and also philosophy, law, and ethics. And I'm saying legal engineering all the time, but I haven't given you any definition because there is no established definition yet. But if you are today type legal engineering in Google, you will see different blog posts or job adverts about legal engineering. But most of them are actually coming from the legal tech industry, and you will probably see diverse requirements and definitions of this new profession. But mostly, according to my observations, what is needed is that, for example, legal engineers don't need to know coding, or they need to have some sort of logical thinking and knowledge in automation and document analysis tools. For example, to make it more concrete, I'm now showing you a legal engineering job advert from a German legal tech company, which is called Brighter. And as you can see, they're expecting a solid experience in working with various market standard tools for document analysis and automation, as well as workflow and document management from legal engineers, but they do not, for example, expect in-depth coding experience, but rather a focus on the professional application of various tools. However, unlike legal tech industry, it seems that in blockchain and in token engineering community, everyone has a similar feeling about what legal engineering might be. So I believe, and I'm hopeful that we're actually getting closer to have an established definition for this profession in this in the token engineering community. To share some of the definitions given in the community, for example, Shaman Boschemger, she was also a speaker in this event series, defines legal engineering as something that refers to creating legally compliant traditional governance models where smart contracts replace many of the paper-based human operations in tokenization. And she is making legal engineering as an essential part of token design. And again, according to her, the questions that legal engineers deal with are like, what is the relevant jurisdiction? What is the relevant regulation? How to design legally compliant smart contracts? and how to react to change of existing regulations so that we can be ready for the Web3, or how to tokenize the existing assets, access rights, and voting rights in a legally compliant way. Another definition is coming from LexDAO, a project from the US. This is actually a decentralized legal engineering guild. And the co-founder Ross defines legal engineering is the idea that we recognize that law is a tool to effectuate how people grow their assets, how they coordinate, and code is definitely a part of how law gets effectively implemented. And when it comes to my own definition, I believe that legal engineering is a discipline where legal conduct is represented in computer systems to implement the law effectively in a digital ecosystem with the help of the principles of legal design. And speaking of legal design, I also want to give a short explanation of it for those who are not very familiar with the concept. So legal design is a new movement, so to speak, in the legal industry, which aims at making legal services more user-centered. So it brings practical, agile methods to make legal services more efficient, clearer, more usable, and friendlier. And legal design has this approach of design thinking. So it starts with the empathy with the user audience that it wants to address. So you define the user audience first, and then you try to understand their expectations from the legal services and also the pain points. And then once you define all of these points, then you ideate a potential solution, and then you turn into a prototype, maybe a digital one or a paper-based. Then you test it with your audience, and then you collect feedback, and you use this feedback to improve your prototype even further until you get a well-functioning or let's say well-satisfying solution. And legal design can help us from information design to system design, actually. So it means that it can help us to create both front end and back end of the legal system. And since it can help us with designing complex systems, I believe that it might be also a promising source for mechanism and platform designs. So to wrap up the definition, I believe that legal engineering is a concept which is a combination of design, tech, and law. And I cannot imagine legal engineering one thing without another. So how does legal engineering actually reflects itself concretely? I believe that there are two application levels of legal engineering. One is on macro level and the other one is micro level. The macro level, on the macro level, legal engineering encapsulates governance and regulatory logics within the ecosystem. Because in real life, law exists in a socioeconomic order, and whether we like it or not, it gets influenced by it. So when society wants to incentivize a certain type of human behavior by economic means, it also codifies it in a regulation to enforce it. So from this point, we can think of law as the software of the society, which governs relationships of individuals between each other and their relationships with society. So on the macro level, legal engineers try to answer questions like, okay, how liability rules can create incentives to reduce risks? What happens if assets are insufficient to pay for harm occurred in the ecosystem? Or how do the administrative costs influence the desired liability system? Here, the administrative cost might be, for example, if your ecosystem wants to outsource the dispute resolution with Kleros, then how the token price of Kleros would affect the liability system, or how the going up and down price of Ethereum would influence the liability system. And also, how will these be reflected in rules and lawmaking procedure? Actually, these questions are not new at all, and they were asked before by Lewis Kaplow in his work, Economic Analysis of Law in 90s. So speaking of lawmaking, maybe we should also take a look at how law is currently made. So we start with the ideas for laws. So a group in the parliament or whomever is authorized to initiate a draft law in a society has an idea and create a draft law and put in a public consultation, maybe get feedbacks and finalize its draft. And then this draft goes through the legislative process of the given country, and it's ratified and adopted. Then this is how we have actually new laws. But it comes with its problems, actually. And in a research called the Systems Engineering Approach to Design of Laws, the researcher found the problems that you see on the screen right now with this traditional lawmaking system. Because, for example, this traditional system doesn't really require societal problems to be defined, or it doesn't assign priorities to problems for solution. It doesn't set goals for laws in terms of measurable outcomes. So our laws do not have actually SMART goals. It doesn't require law designers to have design expertise. It doesn't require modeling or computer simulation of law designs. It doesn't require full accounting of the risks and side effects and cost of laws. It's based on opinions, most of the time ideologies, rather than reliable knowledge. And it doesn't really require the evaluation of outcomes. So the law enforcement can actually waste government resources by enforcing with the outmoded and effective laws. So the question is, would this work with ecosystems? I believe it wouldn't, because ecosystems require a different approach to design governance models and rules, because they are inherently complex adaptive systems. This is why I believe that we should have systems thinking in mind, and we should choose bottom-up approach over the top-down approach that the traditional lawmaking system has currently. So the systems engineering way to design laws would look like this. So we would start first with an assemble of team of experts. So we would collect experts from all academic disciplines. And I believe this is quite in parallel with what I just showed you, the cryptoeconomic system flower. And from there, we move on to the quality design. So we start first to identify the problem and then prioritize the problem. Then we move on to the analysis of the societal problem. And then we create a statement for the law's purpose. Then we ideate a law solution, then model it, simulate it, and then implement it by legislature. But we wouldn't stop there, because all implemented laws would then require having a quality assurance, which means that we would periodically review them to confirm that they are necessary and properly implemented, and it's working properly as well. And if we find something that is not properly working, then we would, of course, repeal that part of the law. And from there, we can also go to the quality improvement standards, which would allow us to correct defects and improve the effectiveness, cost efficiency, clarity, safety, and user friendliness of laws, so that we can have some sort of ideal law in the society. And the legal audience might remember, if they're actually coming from the civil law perspective, they might remember the discussion in the legal theory that de lege lata and de lege ferenda. So the lege lata is the current laws which have weaknesses or vulnerabilities, sometimes really do not work well. And on the other hand, we have de lege ferenda, which is actually, which represents the ideal law. And in legal theory, there are discussions, okay, how we're going to reach to de lege ferenda. And I believe in this respect, quality improvement standards can actually help us. So the systems engineering way to design laws can also actually is also overlapping with the computer-aided design in the process. The process that you see on the slide is how token engineers build ecosystems and the token models. And they start with the ecosystem design. So they first define all the stakeholders in the ecosystem, their values, and then their incentives as well, then they move on to the dynamic model or economic model of the tokens, and then they create digital twin, they simulate it, and then implement, and then they put the ecosystem into operation. So I believe the systems engineering way to design of laws can also match with this design process. For the micro level, the legal engineering deals with the questions of how to make the tokenized use cases regulatory compliant and how to transfer legal conduct into code. So you might be thinking, okay, why are we actually taking regulatory compliance into account right now? And my answer would be that there are draft laws all around the world about this. For example, in Germany, there is a draft law about electronic securities. The draft law tries to be technologically neutral, but it's inspired by blockchain technology. On the other hand, on the EU level, we have a proposal for a regulation on markets and crypto assets, which can have effects in token design. And last week, I have seen this tweet from Caitlin Long, and she's basically announcing that Wyoming jurisdiction in the US will recognize DAOs as a new type of limited liability companies, effective from July 1st. So all these things, all these developments actually are pointing us that brace yourself, compliance is coming. And you will need legal engineers in your token design teams. So as an overview on the micro level, legal engineers would try to answer questions like how to implement legal requirements in design and code, how to create a digital twin of real world assets, the connection between on-chain and off-chain assets, how are we going to ensure that ensure the compliance of ecosystems, for example, legally compliant DAOs, and how to transfer legal contracts into smart legal contracts, like can we use recording contracts? What are the limits of the, let's say, Solidity language? Can we reflect enough flexibility that we have on the legal contracts into smart contracts, and so on? So if I sparked your enthusiasm and interest for legal engineering, and if you want to learn more about like how or where to follow the recent developments, these are a couple of recommendations for you. For example, you can follow the Token Engineering's book project, which is called A Hitchhiker's Guide to Token Engineering. It has a chapter for legal engineering, and it's currently written. So once every work, I mean, all work is done with the book, it will be published. And you can, of course, follow LexDAO, and you can join their Discord channel. Of course, you can join a token engineering community, and you can follow the discussions on its Discord and Telegram channels. It also organizes webinars and also academies. And open law and crypto law reviews would be the last recommendation from my side. So thank you very much for listening, and also staying up until this second. And yeah, I would be happy to answer your questions.
Thank you so much, Esen, for your very interesting and insightful presentation. So we already have a few questions in the Q&A session, and I will start to answer them, to read them. I think the firsts are for Clement. So we have Jan Schroeder saying, I don't really understand why the most honest decision should be chosen in general. Do you have any proof of this assertion? I suppose you'd rather get a decision following what is expected to be the right answer, like the red square in your example.
Yeah, I don't see really like how you make the distinction between honest and right. I would say that in case of Kleros, what is like the right answer is also the honest one. So on do we have any proof on how it's working? So on like Kleros, it's slightly more complex than a simple sharding coin system. But on a simple sharding coin system, you can compute Nash Equilibrium, which in terms of game theory are situations where none of the party benefit from changing their behavior. And in this case, you will also have a Nash equilibrium where the best behavior is to be honest. Like if everyone is honest, you should at one time, the next time step, you should always if everyone stays honest, they all get that's the best strategy for them. Like if only one of them deviate by not being honest, they get penalized compared to staying in the same strategy. So we can show that it's a Nash equilibrium. And on experimental proof, well, it's not really proof, but experimental, on experimental evidence, we first started with a really simple case, which was just about content curation. It was Dodge trial experiment, where we also try to attack the system by offering a reward to try to get wrong decisions. And we did not get a wrong decision made by the jurors. So it was kind of like a good insight that it would work. And Kleros is not like a theoretical experimental system anymore. We've been running for maybe 3 years. Like you had dispute with like significant amount of money. So it's not like it's not that experimental anymore. Like maybe it's experimental if you are in the referential of the financial world, if you are in the referential of the blockchain world, which is obviously way more nascent. I would not call it that experimental anymore. And we have another question still by Jan Schroeder. How do you ensure that jurors on the arbitrator side are not parties on the arbitrable side as well? The answer is we don't, because Kleros is a system which does not require people to give their identity. So we cannot know who is whom. But the thing is we should avoid impact of conflict of interest is that they would only get a slight chance of being drawn. And they are also appealed. So even if they were drawn in the first place, they will be likely diluted in appeals. So even if you could in theory be juror in your own dispute, it's really unlikely that you will get a significant part of the juror pool.
All right, thank you. There's another question from Julia Hugendubel, I think for you as well, Clement. Could you please explain a possible escrow contract in more detail? For example, when one party holds a trade secret and only wants to release it in case of certain predetermined conditions, how could the owner of the trade secret secure the secret and the other side have the security that, for example, in case of insolvency of the trade secret owner?
Yeah, so you have a limitation with those smart contract, which is that a smart contract only has authority on asset it has explicitly been given control of. So in the case of Alice and Bob, only the money Alice put in the contract can potentially be awarded to Bob, not more. And if Bob did not put anything in the contract, even if it makes a really bad website, like Alice could not ask like for damages to Bob, for example, because there is just no asset to move depending of the result of the ruling. Here, in your case of trade secret, you could, for example, ask a deposit, and the party which will reveal the trade secret in violation of the contract could lose the deposit, but you cannot ask anything other than the deposit. So you have this limitation. So in the case of insolvency, it's not even insolvency of the individual or of the entity, it's insolvency of the contract. In the contract, if you make a contract, for example, which would allow to award damages, you could make that, but you will need to have a deposit, and the deposit will be the maximum amount of damages which could be awarded.
Okay, and also she continues, they will get access to the trade secret. Are there services for those escrow contracts?
Oh, so the jurors, they don't need to get access to the trade secret in the first place, like if there is no dispute. Now, obviously, if the trade secret is revealed, well, it's going to be public, so it's not a problem for the juror to have access to it. And you can even make a contract with commit and reveal schemes, where in the contract you will basically reference to a hash of the secret, such that people reading the contract, if they haven't been given the secret, they cannot know what the secret is. But if then you give them the secret, they can hash the secret and they can verify that the hash corresponds to the hash on the contract. So you can basically have elements of your contract which are private until someone reveals them. But you can prove that in the past you contracted with those elements which are private until someone reveals them. That's cryptographic commit and reveal schemes that you can use to do that. And there was another question, but it was not on the Q&A, it was just on the chat, which was, could you go in more detail or to prove if one is a human and unique by ONS? So on proof of humanity, you have two elements you need to go through. The first one is to find someone which will vouch for you, which is already connected. If you are shown to have been a malicious submission, people who vouch for you are going to be removed from the registry. So it's a measure to protect from people trying to submit fake humans. So you need to be vouched. This also leads to some graph where you can see who vouched for whom. So if you can spot like weird patterns, which could be attacks. And in addition, you have a video verification where you will put your address and you will say, I certify I'm a real human and I'm not already registered. And you will also post that as a proof with a deposit. So people looking at the registry, they could, for example, see that, well, you're already registered. Like people actually, they are even using some machine learning to try to match people in people faces to try to see, say, oh, this person looks like this one. And then you can say, okay, are they the same? Not. And if they are the same, you can challenge them. So it's a classic curated registry token economics, plus the vouching, which gives extra security and also means that you basically stake some assets, but you also stake the identity of the person vouching for you, which will be removed if you are malicious.
Thank you, Clement, for answering those questions. I think we can start also with Esen's questions, the questions for Esen's. We have Ucher asking Esen, why choosing a bottom-up approach? In system thinking, the purpose is the main driving force and it comes up bottom.
Well, the reason why is that because in token system, you basically start with defining the stakeholders and then their incentives, then their values, and then this is how you actually come up with the idea of the values of one ecosystem. And so you actually start with the pieces of the ecosystem rather than you say, okay, this is the value and I'm now going to implement it in the ecosystem. So this is why I believe bottom-up approach is more suitable to actually design rules and governance models in an ecosystem.
Okay, thank you. There's another question for you. From you, Chair. So you are looking at a collaborative approach in the design of the system? Yes,
exactly. Because this is, again, like a complex adaptive system, and you have to really have this systems thinking in mind. This is why you cannot really ignore any piece of the ecosystem. You just need to have this collaborative approach so that you can have a good design.
All right, thank you. There's also another question for you on the Q&A section from Clement Lesaege. Question for Esen. Thanks for the great presentation. My startup is running validator nodes for our customers. Running validator nodes have block rewards in tokens. We plan to share the block rewards with our customers. We will not hold custody for their tokens. We plan to use multi-sig wallets, but still need to be sure about some regulative issues. Are there any ready solutions or contracts we use?
I'm not aware of any ready solutions right now, but I would definitely recommend to stay in touch with the token engineering community, because there are many projects going on, and you can actually share knowledge and get more insights. You can also connect with the, for example, token engineers in the US, in just, just in case you also want to be active in the US. So yeah, just please get in touch with the community.
Great, thank you. There's two quick questions for you, Esen, from Michael on the chat. So every step you mentioned in legal engineering must be breakdown in code. This is asked by Michael.
I think what he means is the steps that I talked about during the systems engineering approach to design of laws. So it's actually the overview of how we make the design. So I wouldn't put everything, or I wouldn't break everything down into code, because then because coding is a big task. So before coming to that, I will start with the design. Maybe not on, maybe it can be digitally, it can be anything else. For example, on with token engineering, for example, we start with a paper plan, or paper, I don't know, canvas or something like that, and we basically define the stakeholders and the values and so on. So we don't actually do any coding, and what needs to be coded might be also the outcome of the design. So you have to make sure that everything is right, and will at least have confidence that will be beneficial and useful. Then you can code it.
Okay, thanks. We have the last question on the Q&A section from Arthur Richards. How about the view that laws and systems can be voluntary? For example, participation in a reputation system based on individual choice, and competing system available to be joined, compared. So rather than a quality assurance, instead we get a natural selection?
I mean, what I was actually telling or meaning that we can implement this approach for each ecosystem. So if we, and this would actually customize the design and the rules according to the nature of the ecosystem, because every ecosystem has different purpose, has different values. And quality assurance, I believe that it would go hand in hand with natural selection, because what it requires is that we're going to make a review on the laws that are or let's say the rules implemented, right? And through this evaluation, we would actually see what's working and what's not. And if we find what's not working, it will be actually naturally selected that it will not be chosen next time. So I do not see any contradiction between natural selection and quality assurance.
Thank you, Esen, for answering this last question. Thank you both, so Clement and Esen, for this insightful webinar session. And thank you to all the participants that have joined and engaged, not only on this session, but also the previous session. This is the last episode of Token System. And thank you for attending. I wish you a wonderful weekend, and stay tuned for next events updates on BerChain social media.
Thank you, everyone. Thank you for having us.
Thank you. Bye.
Bye-bye.